defined as the force due to gravity on a particular object, and we have already defined force as mass times acceleration. We're given mass m. The gravitational field tells you the acceleration due to gravity, so mass times the acceleration due to gravity, mg.
So he says that weight is defined as the force of gravity on an object. Is that a fair?
Yes.
If concise restatement. Anybody in the 10%? Yeah. Ellie.
So in the reading, it actually said that if we're going to define weight as the normal force exerted upward on an object by whatever flat surface it's standing on, and they said they were doing that in order to allow, for example, astronauts in outer space to use this.
So Ellie has pointed out that we are defining weight to be what the scale measures. If you're standing on a scale, it has to push up with a certain force. That's the force we call your weight. If we define it this way, then there's a sense to the statement that in orbit, an astronaut is weightless. There is no force needed to float around in the orbit. That's not true. There is a gravitational force, but there's no need for a scale or force from the floor. And so the definition that we use in the text and that we will use in the course is weight is not an intrinsic property like mass of a body, even not considering changes in position in a gravitational field, but weight is what force is required to maintain the body from falling through the floor. Okay, and score for those who read and got this out of the text. Are there any questions on that? So mg is what if it's not weight? Force of gravity on some object of mass m. But that is different from weight. Weight is how much force needs to be supplied, typically through the feet, or how much force is being supplied normally from the table on the mug. Okay, so I have a quaint little passage for you